Imagine you're at the checkout screen after an online shopping spree, about to enter your credit card number. You type it in and instantly see a red error message. Please enter a valid credit card number. Annoyed, you scan back through each digit and you spot the culprit. You put a 7 where a 6 belonged. Typo corrected, purchase complete. But how did the system detect your error so quickly? Well, here's the twist. No one just compared your number to a giant list of valid cards, and the merchant didn't ping your bank either. In fact, the explanation is far more clever. Behind the scenes, a simple piece of math, developed back in the 1960s, checks whether you made a typo. It's called the Luhn Algorithm, named after Hans Peter Luhn, an IBM researcher who patented it back in 1960. And that same trick shows up everywhere, in barcodes, tracking numbers, even ISBNs on books. Let's break down how a credit card number is structured. The first digit is the major industry identifier. For example, Visa cards always begin with 4. The next several digits identify the issuing bank. The digits after that are your individual account number with that bank. And the final digit, known as the check digit, is the one that doesn't carry any account information. It exists purely so the overall number will pass that Luhn math test. Here's how the Luhn algorithm works. First, write out all digits except the last one, which is the check digit. Then, starting from the rightmost digit of that sequence, double every other number. Next, for any doubled result that becomes a 2-digit number, say 14, add its individual digits together, so 1 plus 4 equals 5, and use that. Then sum all these resulting digits. Finally, add the check digit at the end. If the total is evenly divisible by 10, the card number passes the check. If not, it's invalid. What makes this so cool is that the Luhn algorithm catches the most common human input errors, like mistyping a single digit or swapping 2 adjacent digits. For example, entering a 13 instead of a 31, and the math breaks. There's one rare exception though. A swap of 09 and 90 could slip through. So why does this matter? Well, because for merchants and payment processors, catching simple typos quickly is a big win. Instead of sending every number off to a full validation service, which takes time and costs money, they can use this lightweight math test first. If the number fails the check digit rule, it's invalid right away. If it passes, it might be valid, but it still needs full backend verification. There is an important caveat though. Passing the Luhn algorithm does not guarantee that the card number is real or usable. It just means it could be valid. Failing it means it's definitely invalid. So next time you type in your credit card and you see that error message, remember, it's not just the system. It's a clever little piece of math quietly working behind the scenes. That's the Luhn algorithm, turning everyday digits into one more layer of protection.